Thank you for joining this lesson. We're going to discuss linear motion, also some Newton's laws of motion. The figure below shows the pattern formed on a tape in an experiment to determine the acceleration of a trolley. The frequency of the ticker tape used was 50 Hz. On the diagram, we are shown the motion of the trolley. Then this is the tape which was attached to the trolley. Some dots were made by the ticking ticker timer. Calculate the initial velocity of the trolley. With this direction of motion, it means this is the initial motion, and later, because these dots are being made later, that will be the final velocity. Remember to subscribe to this channel and to also share the link with your friends. Now that the frequency of the ticking tape or ticking ticker timer has been indicated, then we can get the periodic time, which is the time intervals or the time taken for the ticker timer to make dots, the intervals between the dots, to be the reciprocal of the frequency 1 out of 50, which is 0.02 seconds. So that is the periodic time. Now, the initial velocity, which I might call u, yeah, that is the standard abbreviation for initial velocity. Then I'll need the distance there, which is 0.01 meters after converting the 1 centimeter. Divide by time, because within that time there is only one interval. That means the time 0.02. This is going to give us 0.5, or rather half, yeah, because when you multiply by 100 and 100, you get 1/2. This will be meters per second. Next, we are calculating the final velocity of the trolley. This will be given by the distance within the final motion there, which is 5 centimeters, easily converted to 0.05 meters, divided by, because now we have two intervals within that distance, then it will be 2 multiplied by the distance or the time for one interval, which is 0.02. Therefore, 0.02 by 2 is 0.04. So 0.05 divided by 0.04 is going to be 1.25. 1.25 meters per second. So that is how we get the final velocity. We proceed to calculate the acceleration of the trolley. Remember, acceleration is usually given by final minus initial velocity divided by the time. Now we're going to take the final velocity is 1.25 minus initial velocity 0.5 divided by the time taken for the velocity to change from initial to final. What we do in the calculation of the time taken for the change in velocity, the dots between these two regions are counted wholly, like 1, 2, 3. Those are 3 dots. Then the dots within the regions, now we take half of them. So we have 1, so we take half in the first region, and here we have 1, 2. So half of the number of dots will be 1. Therefore, we are having half in this region. We are having 3 complete intervals. Then we have 1 interval from this point. So we're going to have 3 plus half plus 1, and that will be 4.5. So 4.5 multiplied by the time, which is 0.02. It's going to be 0.75. Then we divide by, when we take 4.5 multiplied by 0.02, this gives us 0.09. Then now we can get our acceleration by dividing, and this gives us 8.33 meters per second squared now that it is a acceleration. So that is how we get acceleration from the ticker timer. Let me look at the next question. It's telling us to define the term inelastic collision, also the term inertia. So the first term, which is the inelastic collision, remember this is a type of collision whereby bodies merge together. They merge and move together after collision. And we say that this is a collision where both linear momentum and kinetic energy are conserved. Both linear momentum and kinetic energy are conserved. In case we had the other type of collision, which is the elastic one, it's good I mentioned the elastic collision, then this one is described as a type of a collision whereby the bodies separate after collision and they move separately after collision. Therefore, in such a collision, only linear momentum is conserved, but kinetic energy is not. We are also told to define the term inertia. This is the tendency of objects, the tendency of a body to resist change in its state of motion, state of uniform motion on a straight line, or rest. Therefore, bodies tend to resist their state, whether they are at a state of rest or they are moving uniformly on a straight line. They tend to resist change on their state, and that behavior or tendency of bodies to resist change in their state is what we call inertia. It is what led to the law of inertia, or the first Newton's law of motion. Part C. A bullet of mass 20 grams leaves the muzzle of a gun at a speed of 250 meters per second. If the mass of the gun is 3.5 kg, calculate the recoil velocity of the gun. Calculate the recoil velocity of the gun. Therefore, what you're going to have here is momentum before collision. This is what should be known now. Momentum before and after collision is usually the same. In all types of collision, momentum before and after collision is usually equal. Therefore, before collision, both the bullet and the gun were at rest. Therefore, mass of bullet times velocity of bullet. Remember, they are going to give us 0 because they are all at rest, plus mass of the gun times velocity of the gun. They are going to give us mass of bullet times the final velocity of bullet plus mass of the gun times final velocity of the gun. Actually, we could have used letter U at this point to mean initial velocity of bullet, initial velocity of gun, so that we may go to final velocity of bullet, final velocity of gun. Therefore, initially they are giving us 0 because they are both at rest. But now, after the firing of the gun, we will have the bullet with 20 grams. You can divide this by 1,000, moving at a velocity of 250 meters per second. Then plus, for the gun now, 3.5 times a known recoil velocity. So we're going to have 0 equals to, when we take 20 by 250, we get 5,000. Then we divide by 1,000, we get 5 plus 3.5 V. So 3.5 V equals to 5. So this has to be a negative now. So V equals to negative. When we divide 5 divided by 3.5, this gives us 1.43. So now the velocity is going to be 1.43 meters per second. That is the recoil velocity of the gun.